Welcome to the review for Exam 2. We're going to jump right into it here, and we are going to move quick because it's late and I'm tired. This seems to be a recurring theme in my videos. I make them late when I'm tired, so I'm sorry if I sound grumpy. I'm kind of a bit grumpy right now. Anyway, Chapter 13, Chemical Equilibria. In this chapter, we were introduced to the idea that we have forward and reverse reactions happening simultaneously, and that this is what we call a dynamic equilibrium. You should definitely know what a dynamic equilibrium is, and you should know that chemical equilibrias are dynamic. And you should definitely know how to write the equilibrium constant expression. So this, essentially, you should definitely know how to write that, because you will have to do that on the exam. Now, I do want to warn you a little bit here. The way that you're going to write it on the exam is I'm going to ask you to put it into the math editor. Sometimes things can be a bit difficult to put in there, so I will be manually checking those, but I believe it can detect if you put it in correctly. It might have to be something where I manually check it. I don't actually remember. But regardless, I will make sure that that it is checked, and that if you did it correctly, that you'll get credit. So don't worry about that. It might not get graded immediately. But you do need to know how to write an equilibrium expression, and I will expect you to put it in on the exam. I also expect you to know the relative, well, let me rephrase that. I expect you to know what having a really large or really small equilibrium constant means. So if you have a really, really large equilibrium constant, that means that you have a highly product-favored equilibrium. And if it's really tiny, then it's highly reactant-favored. Kp, don't worry about it. It's not on the exam. Heterogeneous equilibria. You should know how to deal with different phases. So you should know, for example, that solids and pure liquids do not show up in the equilibrium constant or in its expression. Alright, so through this whole section here, we are talking about finding Kc, finding the equilibrium constant. If you are given an equilibrium concentration, you should know how to do this. The alternative to this is the next thing that we talk about, which is if you're not given an equilibrium concentration, but you are given the equilibrium constant. You should know how to do this as well, because you will be doing it on the exam. Since this is kind of like everything that we do in these 3 chapters is these kinds of problems, where either you know the equilibrium concentration and you use it to find Kc, or you know Kc and you use that to find the equilibrium concentrations. This will come up again and again, both in the acid and base, but also in KSP. So you will definitely need to know how to do this. It will be on the exam. And so the type of question that this will be would be just, I would give you information kind of similar to this initial information here, and then you would just input a number at the end. So you wouldn't be putting in the equilibrium constant expression or anything like that. It would just be, I would ask you for a concentration, for example, and you would put that in as your final answer. As far as making the x is small assumption, which is what this is talking about here, unless I specifically tell you not to use the x is small assumption, you can go ahead and use it. Feel free to do that. I will tell you if you can't use it. And this is mainly just because as a time saver thing. I don't want you to spend a lot of time trying to figure out if it's okay to use the x is small assumption. I'd rather have you spend that time actually doing the problem itself. Okay, so this is just more examples of that. We did a lot of stuff here with equilibria. Le Chatelier's principle. There is a question on the exam about Le Chatelier's principle. You should know what it is, how to use it. Just to very briefly remind you, this is how we determine how an equilibrium reacts if we make a change to the system. So if we add some of one molecule or another, or we heat it up, or we decrease the volume that the reaction is occurring in, Le Chatelier's principle tells us how the reaction responds, how the equilibrium responds. And again, there is a question over this on the exam. I'll just go ahead and tell you now. The way that the question is going to be asked is essentially, I will give you a reaction. I won't tell you what that reaction is right now, obviously, but I'll give you a reaction, and then I will ask you something along the lines of, see this product here? Here's a whole list of things that we could do. What of these things would increase the amount of this product? So what could we do essentially to shift the reaction to make more of this? So make sure you know how to answer that question. This is just more about Le Chatelier's principle there. As far as catalysts, all I expect you to know is that catalysts don't have an effect on equilibria. All the effect is how quickly you get there. So I do expect you to know that, but that's the extent of it. Okay, so that's chapter 13. So now let's look at some of the acid-base stuff here. So, chapter 14. As far as the definitions of acids and bases, the only one I expect you to have memorized is the Bronsted-Lowry. So I expect you to know that, according to Bronsted-Lowry, an acid is a proton donor, a base is a proton acceptor. It'd be good if you knew the other definitions too, but that's the only one that I for sure want you to have memorized. When you get to organic chemistry, you'll memorize Lewis acid-base stuff. I do expect you to be able to write either the conjugate base or conjugate acid, just depending on how a molecule is reacting. So you should be able to recognize that and label them as well. So if I gave you an equation like this, but I didn't have the labels on it, and I wanted you to put in the labels, say this is the acid, this is the base, this is the conjugate base, this is the conjugate acid, you should be able to do that. Okay, there's more of that stuff there. I do also expect you to know the definitional difference between strong, weak, and negligible acids and bases. So again, those definitions are: strong acids completely dissociate, weak acids partially dissociate, and negligible acids don't dissociate at all, really. And it's the same thing for bases, just with base in the name instead of acid. Okay, so here we're just talking about the difference between those two and how we can treat them differently. We'll get into more of that later. So this is talking about autoionization of water and how that allows us to have this very handy equation, which I will give you, by the way, on the exam. Not that it's all that difficult to remember. And I guess now is as good a time as any to describe to you what I'm going to give to you on the exam. So this exam is really not equation heavy. There's really only one equation in all three of these chapters, and that is the Henderson-Hasselbalch. Still can't speak. You know the one I'm talking about. So this is really the only equation, unless you want to count the equilibrium constant expression, which I guess technically is an equation, but it's different for every single reaction. So because this is really the only equation, I expect you to have this memorized. I will not give you the Henderson-Hasselbalch equation. However, I will give you a page. I guess I can go ahead and pull it up here real quick like. Hold on just a second. Alright. So that was literally less than a second for you, but it took me a minute to pull this this file up here. So this, along with just the normal periodic table and conversion factors and stuff like that, which you probably won't need, but I'll give it to you anyway. You'll need the periodic table, but conversion factors you probably won't. I'm going to give you this, and I apologize for the very poor quality of this. It's a scan of a scan, which quality degrades every time you scan it, but this is what's called the Minding Your P's and K's cheat sheet is what I call it. And it just shows you how to interconvert between different things, specifically related to acids and bases. So it shows you the conversion between H plus and OH minus, how to go from H plus to the pH, how to go from the pH to the POH, and as well as the conversions between Ka, Kb, and pKa and pKb. So none of these equations are terribly complex or anything, but I will go ahead and give you this on the exam. I attached it when I sent in the exam information to the testing center, so they should print it off for you and give it to you when you take the exam. Alright, so moving on. Obviously I expect you to be able to use those equations to go back and forth between OH minus and H plus. You should be able to do that, as well as find the pH. I expect you to be able to do that, both for strong acid and bases, as well as weak ones, as we'll see in just a second. Let's see. This is just more stuff there. As far as like how we measure the pH, I'm not going to test you over those. I'm not going to be quizzing you on names of indicators or anything like that. I do expect you to know these strong acids as well as the strong bases. So I do expect you to have those memorized. Strong bases, those are pretty easy. And I know I mentioned it in the video, but I'll mention it again here. You do actually find slightly different lists elsewhere, but we're going to go ahead and go with this list. So we have 6 strong bases, 7 strong acids. I expect you to remember all of those. So if I give you like a problem where I just say you have 0.1 molar HClO 3, what's the pH? You should be able to recognize, oh, that's a strong acid. That means that I'm actually going to have 0.1 molar H+. I expect you to know all of those. That leads us into weak acids. I guarantee you will be finding the pH of a weak acid solution on the exam, or at least you will attempt. Hopefully you succeed. So make sure you know how to do that, which is what it's talking about here. If I give you the concentration and I tell you the name of the acid and the Ka value for that acid, you should be able to find the pH of that solution. So that's what we're working through here. And the same thing, by the way, goes for bases, which I think is the next topic here. No, it's mixtures. I'm not going to do mixtures other than just to ask you. Let me rephrase this. I'm not going to have you do calculations with mixtures, but I do expect you to know that if you have a mixture, you're only going to be concerned with the stronger one. So I expect you to know that, but we're not going to do calculations with it. Same thing with the polyprotics. We're not going to do calculations with the polyprotic acid, but I expect you to know how to handle one. So I expect you to know that if you have an acid like phosphoric acid, these two Ka values are so far apart that we really only need to be concerned with this one. I expect you to know that. So here's the weak bases. Like I said, I do expect you to know how to find the pH of a weak base solution as well. So it's very similar to a weak acid, just with base molecules instead of acidic ones. Like I said, I'm going to give you that handout. They'll have this on it, so you should be able to interconvert between Ka and Kb. As far as the things that affect acid strength, I'm not going to have you like filling in a table or anything like this. The main thing I expect you to know is just that the more stable the ion that's left behind is, the more likely it is to be ionized in the first place. That's the main thing. So if the ion that's left behind is stable, if it's happy, then it's easier to take its hydrogen away, which is really prominent in the resonance stuff here, but it's true for the previous ones as well. Lewis acids and bases, like I said, I don't expect you to have the definition of that memorized. If you go on to organic chemistry, you will get your fill of Lewis acids and bases, because that's like half of organic chemistry, if not more, is Lewis acids and bases. Acid rain, don't worry about that. I'm not going to test you over acid rain. Okay. So, last group of slides here. Common ion effect is the first topic here, which is related to Le Chatelier's principle. I do expect you to know how to handle the common ion effect, but the main use of the common ion effect is in the next topic here, which is buffers. And you will need to know how to do calculations with buffers on the exam. There will be multiple questions where you will do calculations with buffers. I know there's at least one where I just give you a buffer solution and just say, hey, here's the buffer solution, here's the stuff in it, what's the pH? And then there's another one where I say, here's the buffer solution with all the stuff in it. And also, after you make the buffer, you add a little bit of base or acid or whatever. What's the pH after you've added in that extra stuff? So essentially, you test the buffer in a sense. You added something that the buffer had to consume. And what's the pH after that? So both of those are on the exam. And I think those are the only ones that I put, but don't hold me to that. But I know those two are on there, and I think those are the only two. But if there's more, they would be in a similar vein. But I think it's just those two. But like I said, know how to do buffer calculations. So that will again require you to remember I don't know why I'm writing this, because it's going to be on the next slide, or 2 slides away. The Henderson-Hasselbalch, where is it? Oh, there it is. So, know this equation, have it memorized, and know how to use it, because you will need to use it. Okay. More about buffers. I already talked about this. Like I said, this will be on the exam. Know how to do it. So figure out what the initial pH of the buffer is. Don't figure out the initial pH. Figure out what you have in the buffer initially. Figure out how the addition of either a base or an acid will affect it to give you new numbers, and then plug that into the Henderson-Hasselbalch. So that's what it's doing there. Basic buffering systems. I don't think I did any basic buffering systems. I don't remember doing one. We'll go ahead and go with that. We'll say I didn't do any basic buffering systems. But I mean, even if I did, if you remember we don't change anything. Everything's still exactly the same with a basic buffering system. You just have one extra step where you have to change that pK, because you would have a KB instead of a Ka, so you have to do a little bit of mathematics to convert that into a pKa. But that's the only difference. But like I said, I don't remember putting in a basic buffering system. I'm pretty sure I used all acid. Okay, as far as pH range and pH capacity for buffers, all I expect you to know is that the higher the concentration of the buffer, the greater the capacity is. And the closer you are to the pKa of your acid or base, the better it can handle any stuff you add in. So I'm not going to have you doing calculations like this one, where you actually work out the amounts of an acid or a base that you would need to get a pH of a certain value, but you should know how to think about them, just in general. As far as titrations, so this is the last really big topic of Chapter 14 was titrations. The main thing I want you to be able to do is to find the pH at any one point on the titration curve. So that is something that I could ask you to do. So I think, let's see, where do I have it? So yeah, so right here. So these 3 slides essentially describe how you would do that. So there's 5 different points in a titration curve that are mentioned here. And I specifically tell you in each of these 5 points how you would find the pH. So this slide here is just talking about point 2 here. So in each of those 5 points, I tell you how you would find the pH. And so what I will do on the exam is I will either just pick one of these at random and have you solve for the pH at a certain point in the titration. So I would give you enough data to find the pH at that point in the titration. Or I will give you a question where I list all 5 of these, and you have to tell me how you would solve to find the pH. So you would have to tell me, for example, in the initial state, you would treat it like an acid equilibrium. That's how you would find the pH. If you're after the initial, but before the equivalence point, treat it like a buffer. At the half neutralization point, you would just take the pKa of your acid, and that would be the pH. Or, sorry, or yeah, I guess that, yeah, because you would know the acid. So you just, the pH is equal to the pKa. That's how you would find it. If you're at the equivalence point, you would find the pH by treating it like a weak base solution, because the only thing that's in solution at that point that has an effect on the pH is the conjugate base. And then at the equivalent, or past the equivalence point, you would treat it like a strong base solution, since OH minus is in excess. So I will either have you solve for one of these 5, or I will have you tell me how you would solve for those. So know how to do that. But I will not, repeat, I will not give you a question like this one, where you have to do like 3 pages of calculations to solve for the pH. Like I'm not going to have you do that. I'm not going to have you spend 30 minutes on one problem. Okay, and I also do expect you to know how to identify different points on the curve. So like on this curve here, I would expect you to know that that's the equivalence point, and I would expect you to know that this would be the half equivalence point, because it's halfway between the initial and the equivalence point. So just understanding the basic shape of the curve, really. Alright, so again, all this stuff about indicators, I'm not going to test you over indicators. Chapter 15 is the last chapter, and it really only has the one topic, solubility. And as far as these, what I expect you to be able to do is, if I give you the KSP, I expect you to be able to find the solubility. Solubility. I'm misspelling things. This is why I shouldn't make videos at midnight. And if I gave you the solubility, I expect you to be able to find the KSP. And if I remember correctly, I have you do both on the exam. I think I have you do one of each, if I remember correctly. So know how to do both, because you will be expected to do both. So I will give you something along the lines of, let's see, here's a problem here. So like something like this maybe, where this is the solubility process that's happening. This is dissolving into solution. And I have you figure out, so in this case, it actually wants you to find the solubility product, which is the KSP, and it tells you what the concentrations of stuff are in solution. So again, that's what I was saying back here. That would be this process. You're given the solubility, and then you're asked to find KSP. But I also expect you to be able to do the opposite, which is, I believe, yeah, what is done here in this problem. So going in either direction. And this really is actually, I know, just because of the terminology, it seems like it's different than what we've done before. This is actually the exact same thing that we've done in the last two chapters, where, if you remember in chapter 13, we would use equilibrium concentrations to find the Kc value, and then in other situations we would use Kc to find the equilibrium concentrations. It's the exact same thing we're doing here. It's just instead of Kc we have KSP, and instead of saying equilibrium concentrations we say solubility. But solubility is the equilibrium concentration. That is the exact same thing. So I know it might seem a little different just because of the terminology. It's actually exactly the same. Okay, so that's just all the same stuff there. And I also do expect you to know the difference between the solubility product, KSP, and the solubility. So what changes for one might be different for the other. So for example here, the solubility product does not change with the pH or the presence of common ions, but it does, the solubility does change with those. So just understanding the difference between the two. I expect you to know that. Okay, so this is just kind of more the similar type stuff, but including the common ion effect there. As far as factors affecting solubility, really all I expect you to know here is just that these have an effect. I didn't put any questions in where I was like, here's this molecule, tell me if it'll be more or less soluble if I put an acid in with it. I didn't do that. Didn't put anything like that. But I do expect you to know that pH can have an effect on solubility. Same thing with complex ions. I expect you to know that that is something that could have an effect on the solubility. It just depends on the ions involved. And then this last thing here, the selective precipitation of ions, I'm not going to have you doing anything with that. It's a very, very useful process, don't get me wrong, but there's not really a good way for me to test you over that. Really the only way to do that is in a lab. Alright. Well, I hope that was helpful. I hope it didn't come off as too grumpy making the video. But I really needed to make it tonight since people will be taking the exam possibly within the next day or two. So if you have any questions over this, do not hesitate to email and ask. And I will do my best to get back to you as quickly as possible. Good luck studying for the exam.